Alright, hello everyone, welcome back. First video in a while. Anyone that's in singles watching this, probably your first time watching, hello. Uh, I made this paper. If you haven't tried it, you should try it. It's good practice for your mock that's coming. Oh, no, your mock, your actual summer exam that's coming up. Um, yeah, and this is the video explaining the solutions to this paper. It has some quite nice questions in my opinion. Um, it is a bit. I mean, I do admit it's a bit imbalanced. There are a couple of questions that are a lot harder than everything else, but most of the questions are of a pretty moderate difficulty, in my opinion, for what's going to be on your summer exam. Uh, so let's get into this video. It's basically just going to be going through the mark scheme. I'll link the paper and the mark scheme in the description. Um, and yeah, let's just go straight into it. So this first question, I wanted to start with a bit of a break, and then I kind of or I wanted to start with a bit of a like an easy question, and then I kind of just thought up this part C, which is not very easy. But so part A is just completing the squares, shouldn't be very difficult. And then this is part B is just the discriminant. Um, this is stuff you learned ages ago. I mean in GCSE and then the start of the year. Um, for part C, so what we had to do here is that you had to substitute everything in the correct order. So you had to turn all the x's into. You should probably have used your completing the square form as it is said in the question. Um, Otherwise, it becomes a lot harder. So you can multiply the entire thing by 2, and then substitute all the x's for e to the x's, and then you can uh, do that, and then there's a minus 2k on the end because it's the entire function minus 2k, and then set it equals 32. If you rearrange this correctly, it should end up the k's should end up cancelling, and you should end up with this equation, which is e to the 2x or e to the x squared plus 6e to the x minus 16. But just for any use with these method marks, so M1 basically just means, if you haven't seen it, like looked at a mark scheme before, M1 is method mark. It's if you like no M1 unless it says specifically, you don't need to have the correct numbers for any M1 mark. It's just for the attempt of doing something that like the mark scheme wants you to do. This D here means like dependent, so you would need the previous mark to be able to get this mark. And then A1 is accuracy marks, which are for the correct answer, which are usually at the end of questions, but sometimes they're in the middle of questions for getting correct expressions. So here you get the M1 for getting 2 out of 4 correct aspects. There's 1, there's the 2, there's the e to the x, there's the minus 2k, and there's the equal 32. They're the 4 aspects of the transformation. And if you get 2 of those right, you can get this first M1. You need there's words in bold here that explain when to give the M1 marks as well. And we're going to get this equation, and we're going to solve this as a quadratic, a hidden quadratic, to get this. You also need to discount a solution. If you get an e to the x equals a negative number, you need to discount that solution because the solution is non-real or it doesn't exist, to be able to get this final accuracy mark. There's a bit more detail on how this marking system kind of works with the discounting the solution. SC just means special case, so SC1110 just means like you get 3 marks, and it's a special case. So and sorry, you end up with x equals ln, so you get e to the x equals 2, x equals ln 2. Right, next question, we got a vector question. Here you can either use, this is the method that I would expect most of you to be using, is cosine rule. If anyone I know is watching this, you might have taught you dot product, which is this mark scheme here. So for the cosine rule, you have to find the magnitude of all 3 of the vectors and find this vector AB here that isn't given. And then you have to use your cosine rule, reverse cosine rule. It doesn't matter if you use like the pre-rearranged version or not. And then you need, for this A1, you need exactly cos x equals this, or better just means like rounded more. And this could be anything that rounds to a negative 0.289. There's also, you see this AWRT, just means anything that rounds to that number. So there should be an AWRT here actually, and then you get the answer of 107 degrees. And then for the dot product, you can, if you see the dot product and you see the magnitude of at least one of the vectors, then you get an M1. And you get an M1 for doing either ca.cb or cb.ca. They're the exact same thing. Just if it just cannot be, to get this M1 mark, you cannot do ac.cb or something like that. They have to be going from C to one of the vectors. And you also can't just do it on your calculator as well. And then using the other formula of the dot product, you can get this equation, and then you get your A1 for getting the answer. For part B, this is just some GCSE trig. Add another note for this question. Oh, no, for this question. Another note for the paper. I've added a lot of show that question. So all of like the part B's and the part C's you should be able to do without being able to do part A. So for this question, for example, you have this angle. So finding the area of the triangle is not very difficult. So you just a site of half AB sine C gives you an M1, or actually no, not a site, a use of half AB sine C. You have to try and substitute some numbers into this equation. You can't just write it out. And then the area is 30. Definitely part B of this question is by far the hardest question on the paper. I don't know why I was so adamant on adding it to the paper, but anyway, we're here now. This question, you can separate these logs into log base 3 of 9 plus log base 3 of 2, which ends up being p plus 2. Part 2, or part II, is just log base 3 of 2 minus log base 3 of x, which is p minus q. Part 3, I added some index laws into this. This is not very difficult index laws. I actually need to add it because I was trying to add most of the topics from your specification onto this paper. You have to do a little bit of simplification. You got log base 3 of 27 root x, and then you use your log separate law that you used on part I, and also the power rule where you can bring the power to the front to get 3 plus half q for your answer there. Now part B is interesting, so unless you know me or you've talked to me and learned math from me, you might not, or unless your teacher's just great, you might not have heard about this change of base law, because this isn't taught very often, even though it's fully in the specification and fully, it's fully in the specification and it's definitely fully in the formula booklet. So if you looked carefully in the formula book here, because you are allowed the formula book, then you might have seen how to do this question. So you get a method mark for one change of base law, another method mark for a second change of base law, and then an accuracy for this answer here. And I didn't want to leave it at that, so I did a nice work solution here. So the change of base law is that you see here, this is log base e of 4x, right? Ln 4x. And you can separate that into just log base whatever of the thing divided by log base whatever of the base of the original logarithm here. So this turns into log base 3, because we want base 3 in this question, because that's what our p's and our q's are in terms of. So we can turn this into log base 3 of 4x over log base 3 of e. Next, this second change of base law, you can do again here to get 1 over log base 3 of e is just ln 3. And then now you can simplify this expression to this, use your log product rule thing, and then you can turn this into ln 3, 2p plus q. There's a couple of ways you can do this question, but 2 change of base laws are necessary for, I think, every single method for this question. You need to do 2 different change of base laws, but there are multiple ways you can do this. All right, this is a bit of a nice question I added. It's quite an accessible question because basically everything is shown that, and also it's just a nice question. Sorry, I've skipped everything. So first you get this mark for 9-0, only the correct answer. You just the way you do this is by setting it equal to 0. Next, so we want the points of intersection of the 2 functions. So we're going to set them equal to each other and 4th roots or square root twice. So you get the plus or minus. Just make sure the plus or minus is in the final answer. You do not need the plus or minus necessarily to get this M1 mark, but you do need the plus or minus for the A1. And then part C, I was going to make this where I didn't put this statement about considering both possibilities of the plus or minus, but I decided to leave it in just to make it, again, more accessible. So you consider the plus and the minus, it's going to give you 1 and 81 for the x, but you can see here that the domain of this function, or just the values that it takes, is from 0 to 10, so it cannot be 81, which means that it's going to be 1, and then you can substitute that back in to get 116. Now part D, I had to include binomial expansion somewhere, so I decided to include it here. So you need to do a clear attempt at binomial expansion to get the M1. 5 terms and 3 out of 5 correct coefficients, including one of C or D for this other M1, and then the correct expansion. These are the values of C and D, and obviously the rest of the values are in the show that. Right, part E. So the way you're supposed to find this area is to find the area of this triangle here, and then the area under the curve from 1 to 9. So you get the area of the triangle being 8. You get an M1 for deducing limits. These have to be... You can't just take two random numbers for this M1 mark. You can get this... or no, you can't actually get any of these marks, actually. You need to set up limits that you have deduced from an actual, like, situation. You can't just pick two random numbers and get this M1 mark. Even if you made a mistake, you still have to show that you made a mistake instead of just picking two random numbers and not knowing how to do it. And then now you can set up this integral, so it would be the integral from 9 to 1 of this, because that's the whole reason I made you expand it, so that you can integrate it. And then you get A1 for just doing I means this integral here, like without adding the triangle, and then you get the final mark for adding the 8 onto the total area. Right, next, so these last two questions are a lot harder than probably anything that will come up on your exam, but I mean, the grade boundaries are lower on this exam, so who cares? So for this question, this is a classic type of something that you haven't actually learned yet, but there's a way to do it which you have learned, or you might have learned, which you should have learned, which is doing dx over dy. So you need to get x in terms of y. And it says in this mark scheme here, x squared equals h of y is not sufficient, so you can't just add y minus 3 to the 4 to both sides. You have to square root it as well. And it says x is greater than 0, so there's no plus or minus. You don't have to say that. And next, the reason why there's 2 marks here is because this is a very difficult derivative, because you have a nested square root with a weird, like, chain rule kind of thing, which is going to end up giving you a big fraction, and this needs to be correct for A1 to be achieved. And then A1 for A equals 25, B equals 2, and the fully correct expression, which is this here. So your dx dy will be 1 over this, by the way, because that's what the rule you have to use. Dy dx equals 1 over dx dy. And then you're going to find your dx dy, do 1 over that, and get your final answer. Right, part B. So where the tangent to the curve is parallel to the y-axis is when the gradient is infinity, because if you think about it, the y is going up infinitely while x isn't moving at all. So if dy dx is infinity, you can do one of two things. You can either say that the denominator must approach 0, or we can say equals in this case, because we're not being strict. So we can either say the denominator of dy dx, so the 2y minus 3 cubed equals 0, or we can say that dx over dy is 0, because 1 over infinity is basically 0. So now this is the hard part, getting this, and then after you figure out what you need to do, it's just doing 2 brackets y minus 3 cubed equals 0, get y equals 3, substitute it back in, and then you get your answer. Now, this question is a bit harsh. It's very harsh, but for multiple reasons. So, firstly, this thing here, I should have put in bold. That's kind of my fault. Where h is measured in tens of meters, you can lose, I think you lose 2 marks in this question if you don't see this. If you were to fully complete the question and get it right, you would lose 2 marks if you didn't do this measured in tens of meters. So, this first thing, you have to substitute 0 in and then multiply your answer by 10. So you can either leave it in one of these 2 forms. So now this next part is not easy whatsoever. So we have to do a very difficult product plus chain rule here, especially with the e to the sine 2t plus pi over 3. That's 3 chain rules, or no, 2 chain rules that we have to do right there. Just make sure to multiply by these 2's as well. Well, that is one of your chain rules, but that's something you should kind of remember at this point. And this will be your, you get an M1 for just attempting product rule. This should be dh by dt, by the way. This should not be dy dx. But you get this expression for dy dx, or dh dt, and you need, to be able to get the A1 here, you need to get a fully correct expression. For the M1, you just need to attempt the product rule. I think this should not... Oh, sorry, that's the last question. So anyway, ignore that little break. So yeah, you need A1 for this fully correct expression, M1 for an attempt at product rule. Now, and then you get A1 for and then, yeah, sorry, then you get an A1 for rearranging to get this, because you have to divide by you have to set dy dx to 0, divide by this, and also state that this has no solutions, which is gonna refer back to the other question. If you want extra information about like what you have to say when you're dividing by variables, and then you get an accuracy mark for this correct expression here. Then this next part you can do without like any of these, without the hell that is part B. You don't actually need part B to be able to do part C. So you just solve this quadratic, get sine 2t plus 3 equals k, and then you also have to find a range of values for 2t plus pi over 3 to be able to get the question right. But you can get this M1 mark for doing not much work. And then you need to multiply your final answer by 10 after doing all of that to get your answer of 14.6 meters. Right, moving on to mechanics. I was really happy with this question. I do think that this should be 5 or 6 marks, but I didn't have enough marks to put it on the paper since it's 75 marks. Which is unfortunate for you guys, but that's just how it works. I don't know. So this first part's quite easy though. So you need to do 2 equations of motion for P, because you need to think about friction, which is pulling left. And for friction, you need R, and for R, you need to resolve vertically. So it would be R equals 2G, and then you can resolve sideways, which is T minus G, because it's a half times 2G, equals MA, and then you resolve Q, which for another M1 mark, to get, that's going to give you 4G minus T equals 4A. And then now you can solve these equations simultaneously to get these 2 values for T and A. These should have units, actually. You need newtons here to get this final accuracy mark. That's my fault. Now part B, this is not easy at all, but it's something that could easily come up. So these types of connected particle questions are not easy whatsoever. So firstly, what you have to do is, well, firstly you should read this, but in the answer, the first thing you have to do is find the final velocity of P from when it goes from here to here, the final velocity when it's about to slip off the plane, using S equals this, U equals 0, and acceleration is whatever acceleration is G over 2. So you can find your final velocity. Now you have to re-resolve. So after it slips off the plane, it's going to be going down with 2G, force of 2G newtons, and it's going to be going back. There's going to be this frictional force here of G over 10 newtons is going to be acting on it as well. So you're going to need to account for that, re-resolve, get your new acceleration, which is going to be 19G over 20. If you don't do that, then you're not going to be able to get, you're going to lose like 3 marks if you don't do that. And then you have to set up a new SUVAT with your initial velocity being your final velocity from earlier, because we're modeling a new situation now, which is the start of our new situation is the end of the old situation. So our U is going to be the same as this V, because it says here that any slowdown from P, no rotational force lost. There's no slowdown from P moving to freefall, and all horizontal velocity is transferred into vertical velocity when it slips off the plane, which is crucial information because that means that we can do this. We know T equals 2 because it says in the question, and we found our new acceleration. So now we can find S, which is going to be 16 over 5 G meters, which it says in the question, obviously. Right, yeah, not easy question, but let's move on to projectiles now. So you get an M1 for doing, I mean, usually I would say that like for M1 marks you can do like anything, but for this specific question, there's not really any mistakes that you can make for these first 2 M1 marks. I don't really see how that can even happen. You get an M1 for doing S equals UT plus half AT squared in the X direction, M1 for doing it in the Y direction, and then you get an M1 mark for trying to eliminate T in any of the equations. You're not going to get very far if you try to eliminate T in this equation, but you still get this method mark. And then now, it's just a lot of algebra. So I said you get this method mark if you either just use the identity, the sec squared alpha equals 1 plus tan squared alpha, or which is this one, or you fully simplify the expression and you don't use the identity. So it's one of these two things. Because if you do both of them, then you're going to get this A1 mark. But if you only do one of them, then you can get this this M1 mark. Next, part B. So this is going to be, you use this again. If you can't do part A, just use this equation for part B and move on. So next we can get a quadratic, and so you substitute 1 into x and 0.5 into y, and then you can get a quadratic in terms of tan alpha. When I say, when it says this M1 mark says quadratic, it means like it needs to be in the form like a tan squared alpha plus b tan alpha plus c equals 0, not some like just substituting it in type of thing. For this method mark, you need to, is another thing from 1c, which we've already mentioned a couple of times now, where you have to find the solution tan alpha equals k and also discount the solution tan alpha equals minus k, because you're going to get a solution that's, sorry, no, this is going to be, this is wrong. It's going to give you a solution of tan alpha equals 1 and a solution of tan alpha equals 3. And you have to discount tan alpha equals 3 because it says here tan alpha is less than or equal to 1. So that's going to give you tan alpha equals 1, which is alpha equals 45 degrees only. Right, next, I tried to keep the stats down to a minimum and a decently easy question, just because no one likes stats. And I managed to stuff every single stats topic into one question, so that's good. So firstly, this is just a classic discrete random variable question. Add them all up, set them equal to 1. So add like k plus k over 2 plus k over 3 plus k over 4 plus k over 5 equal 1. Solve, get this, and then you have to do your probability distribution table, which is just going to look like x at the top, p of x equals x on the bottom, and then you just substitute like 60 over 137 and then 60 over 137 over 2 all the way up to 5. Now part B, this is a very generous M1 mark here for just attempting to multiply different values of little x or just considering the probability of multiple events in general, and just like noting that on the page. And then to find this answer, what you need to do is you need to say that the only situations where this is going to be greater than or equal to 100 is either if x1, x2, and x3 are all 5, or if one of them is 4 and 2 of them is 5, which is going to have 3 combinations. So what it's going to be p of x equals 5 cubed multiplied by 3 p of x equals 5 squared times p of x equals 4, because there's 3 different combinations, and that's going to give you the total probability of the 3 multiplied numbers being greater than or equal to 100. Next, I try to make this question more elusive by using the word discrete uniform distribution, but I just ended up making it not work at all, so I just kind of gave in and made it easier. Notice I said easier and not easy, because this last part isn't easy at all, because it's not something you see often. But part C, so part 1's really easy, like anyone could probably do this. You set up your binomial distribution and put it in your calculator. Now part B, you need to try and apply the multiplication rule, and also you need to state that p of x is less than 5 equals p of x is less than or equal to 4 for this M1 mark. And you get, this is for correctly applying the multiplication rule to get this as your answer, and then now you can just put in your calculator and get that answer. Right, that is the paper. I hope you guys enjoyed that, hope you guys did well, hope it gave you some good revision, or hope it taught you about a new style of question, because all the questions here are styled in a way that they definitely could come up, except maybe this won't come up, but it's a nice challenge for you, I guess, if you needed it. But yeah, I'll see you guys next time, hopefully for next year maybe, for any future singles that come to this video. But again, I'll leave the mock in the description and the mark scheme in the description as a link, and I'll see you guys next time.